Today, we're gonna learn the science behind hurricanes.
Right now, I'm stuck in the middle of Hurricane Irma, which is one of the biggest storms we've seen in a while. It sustained winds over 180 miles an hour for 36 hours straight. The storm has already wreaked havoc on many Caribbean islands and the Florida Keys. And here, where I live, it's about to make a direct hit and potentially flood the home I've grown up in my entire life. So the question that's been floating around in my head lately is, how are these storms so powerful, and why do they cause so much damage? Well, simply put, hurricanes form because of wind, and wind is caused by the uneven heating of Earth. You see, when an area of Earth's surface is heated more than another region, that region becomes an area of low pressure. As you may know, warmer air has more energy and is thus more spread out, meaning the air is less dense and has a lower pressure. The surrounding air that is more dense then rushes in to fill that low pressure. We can see the same principle in my ping pong ball launcher. All the air is evacuated from the tube, so when you puncture the seal, the outside air rushes in to fill it. Except in the case of a hurricane, that area isn't quite a vacuum. And it's also really freaking big. Now this same principle is what makes any old thunderstorm. But in the case of most of our Atlantic hurricanes, the warm water in the ocean feeds the hurricane. You see, these storms suck up that warm water vapor into the clouds, where they condense and make bigger clouds and a bigger storm. Now this process can go on for a while, as long as there's a supply of that warm water. In a typical storm, they hit land not long after forming and they diminish. But a lot of hurricanes, like Irma, start in the Horn of Africa, with a lot of warm water to fuel them and very little land to stop them. Another reason hurricanes grow so large is because of their vortex nature. These hurricanes spin because of the rotation of Earth. Now the Earth of course spins at the same rate of one rotation a day, but depending on your latitude, you have to spin a shorter or longer distance. At the equator, the Earth spins faster, as it has to cover nearly 25,000 miles. But at 45 degrees latitude, it only has to cover around 18,000 miles. So as those winds from the storm move north, they're going faster to the east than the Earth below, and thus to move east. The same thing happens in reverse for winds traveling south. These forces make that classic hurricane shape. Because of this shape, the outer edges of the eye suck up huge amounts of water vapor, and are huge areas of low pressure. Now, hurricanes are rated based on their wind speeds. And while high winds can cause a ton of damage, typically most harm is caused by flooding. Flooding is normally caused by the huge amounts of rain these hurricanes bring. Just recently, Hurricane Harvey brought over 50 inches of rain to some parts of Texas. But another problem that could be equally bad, or even worse, is storm surge. A combination of winds from the hurricane, waves, and even low pressure drive up sea levels. Then when you mix that with high tides, you can see storm surges well over 20 feet. Quite a few years ago, we were hit indirectly by a tropical storm. While we only got a few inches of rain, we saw a storm surge of about 2 feet, which allowed me to kayak in my driveway. Luckily, my house didn't flood during Irma or get any major damage. At the last minute, Irma shifted its track and ended up making landfall quicker than anticipated, which weakened the storm. It also hit to the east of us, which caused a lot of the storm surge to be reduced. But not everybody was this lucky, and a lot of people were really heavily affected by Irma. So if you'd like to donate to those people, I've left a link to the Red Cross down below. And now, I'll leave you with some damage that it's caused to my hometown.